So, with the exponential graph, okay? For the exponential graph, it's maybe I would say the easiest one to draw, okay? Because with the exponential graph, you can substitute three values, -1, 0, and 1. -1, 0, 1. And that's enough to see what it's going to look like. If I put -1 into the graph, a half times 3 to the power -1, okay? This is going to be small, because 3 to the power -1 is 1/3. So 1/2 times 1/3 is 1/6. Okay? If I put 0 in, a half times 3 to the power 0, 3 to the power 0 is 1. So a half times 1 is a half. And then if I put in half times 3 to the power 1, I'm going to get 3/2, which is 1,5. So most of the time, by putting in -1, 0, and 1, it's enough to see what it's going to look like. So I can see at -1, it's 1/6. So it's very small. -1, 1/6. Very small. Very close to 0. At 0, it's a half. Okay? A half. And at 1, it's 1,5. At 1, it's going to be between 1 and 2. 1,5. Okay? If you feel like after you put in those three, it's not enough for you, you can put 2 in as well. Or -2 to make sure. But it should be enough to see that this graph is basically going to go like this. Okay, to get the idea of where it's going. And this way, you can just extend it a little bit and then put in the arrow. Then you drew the graph. Okay, so what I want us to also look at is after you got your graph, okay, if you're done, you can even take away the dots, you can make it bigger, you can just make sure it doesn't make sure it's gradual, okay? Rather turn the page a bit to make sure when you draw it looks good. So we drew here y equal to a half times 3 to the power x. Okay? Now, one of the important things is to know how to do reflections. And with all the graphs, you need to know how to do reflections. So there's two ways to reflect the graph. You can reflect the graph in the x-axis, this way, and then this is your mirror, the x-axis. Or you can reflect the graph in the y-axis, like that. Then you got your reflection that way. So when you reflect in the x-axis, okay, reflection, you can just write this down. Reflection in the x-axis. When you're reflecting the x-axis, you just put a negative in front of the function. Okay, so whatever the function is, let's say the function is fx, then the new function will be negative f of x. Okay, so in this case, if it's fx equal to a half times 3 to the power x, then the reflection would be negative f of x is negative a half times 3 to the power x. So there's the new equation. They might say, for instance, what is the equation of g? They might do it like that. They might say, what's the equation of gx if gx is the reflection of fx in the x-axis? Think about that question. What's the equation of gx if gx is the reflection in the x-axis of fx? And then you can say, okay, so gx will be negative half times 3 to the power x. I just put the negative in front of the function. Okay, so then the reflection would be on this side, and there's going to be the reflection. Okay, so if you want to sketch the reflection, I'll just take away that part, reflection. Then the reflection will basically, that coordinate will go this way, that coordinate will go this way, and that coordinate at 1,5 will go this way. All of them are reflected. You see what happens? What happens is the y value there, positive 1,5, becomes negative 1,5. Okay? The half becomes negative half because I'm reflecting in the x-axis. So my new equation will look something like this. My new graph will look something like that. Okay, and it's reflected from there to there. Okay. The other option is to reflect in the y-axis. Okay, there's your y-axis, okay, reflecting the y-axis. Then all you do is you change the x to negative x. So when you reflect, this was reflect, okay, I can put it in here again, reflection in the x-axis. Now a reflection in the y-axis. Reflection in the y-axis. Now, if the graph is f of x, the new graph will be f of negative x. Okay, so these two summaries are very important. Okay, this one here, very important, and this one here. Okay, actually just that part there you can say. Reflection in the x-axis, fx becomes negative fx. Reflection in the y-axis, fx becomes f negative x. So only the x value changes signs now. Okay, so if I look at the reflection in the y-axis, this is your mirror, so that part goes this way. So think about it, if x becomes negative x, then it means that 1.5 becomes negative 1 and 1,5. It was 1,5 where the x value is 1, now it's negative 1 and 1,5. The 1 over 6 there, negative 1, that 1 over 6 at negative 1 becomes at 1 over 6. So the coordinate on this side goes that way, the coordinate on that side goes that way. So just swap it out. X becomes negative x. Okay, so then the graph would be there. Okay, and then this part will basically go up like that. See, then it's the reflection. And then this graph would be y equal to 1 over 3 times 3 to the power negative x. Okay, reflected from there to there. Okay, so if I say fx is a half times 3 to the power x, then gx, the reflect, or let's make it hx. Hx would be a half times 3 to the power negative x, where hx is the reflection of fx in the y-axis. The y-axis. And remember, the y-axis is where x is equal to 0. Okay, and the x-axis is where y is equal to 0. So they can either say reflection in the y-axis, or they can say reflection in the line x equal to 0. Okay, the y-axis is the line x equal to 0. And the x-axis is the line, the x-axis is the line y equal to 0. So they can say it like that also. They can say, what is the reflection in the not x-axis in the line y equal to 0? Okay, there. You must just remember, y equal to 0 is your x-axis. Your x-axis is y equal to 0, and your y-axis is x equal to 0. And you can get the reflections.